There are 9 area formulas that you're going to need to memorize. The first 2 formulas are the formulas for the parallelograms and the triangles. The area of a parallelogram is going to equal its base times its height. That's going to work for all parallelograms. Where this bottom length is the base and the height forms a 90-degree angle with the base. This formula also works for rectangles, which are parallelograms with a right angle, where this bottom length is the base and this side is the height. They also work for squares, where a square is a parallelogram where all the sides are also the same length with a right angle. This bottom side will be the base and this side will be the height. The second formula that you need to memorize is the formula for the area of a triangle. Well, a triangle is really half of a parallelogram. If I draw in the diagonal of all of these parallelograms, I get 2 triangles. So the area of a triangle is this area times 1/2. And that will work for any triangle. This bottom side is the base, and the height is actually the altitude of the triangle. If I have a right triangle, this bottom side is my base, and this leg is my height. And if I have a obtuse triangle, this bottom side will be my base, and the height is actually outside the triangle. If you remember, I can have an altitude outside of my triangle if my triangle is an obtuse triangle. So memorize these 2 formulas. In problem number 1, we need to find the exact perimeter and area of the figure. The exact answer will be in simplified radical form. That means all of our square roots have been simplified, all of our fractions are in lowest terms. We have an equal angular triangle. And in an equal angular triangle, all the sides will also be the same. So if this side is 10, this side has to be 10, and this side has to be 10. So the perimeter for this shape is just 30 units. It's 10 plus 10 plus 10. The area will be a little bit trickier to find. It's going to be 1/2 times the base times the height. Well, I know my base is 10. So it's going to be 1/2 times 10 times the height. The problem is the height of this triangle is not 10. This length is 10, and this length is 10, and this length is 10, but this altitude, this height, is not 10. So we have to figure out this altitude another way. Well, we can problem solve and look at this triangle as a 30, 60, 90 triangle. If I look, I can cut my equilateral triangle in half and make a 30, 60, 90 triangle. This side is going to be 5. This side is already 10. So this side right here is going to be longer than this side, but shorter than this side. How much longer? Well, it's going to be my shortest side times the square root of 3. So the height of this triangle is 5 square roots of 3. Now I need to simplify. I have multiplication all the way across my problem. So I have 1/2 times 5 times, or excuse me, 1/2 times 10 times 5 square roots of 3. I don't need to distribute this 1/2 because I don't have a grouping symbol and I don't have a plus or a minus sign. So the first thing I want to do is just take 1/2 times 10 and get 5. Now in reality, there's a multiplication between this 5 and this square root of 3. So I can take 5 times 5 and get 25 square roots of 3. And that's going to be in units squared. So my perimeter is 30 units long, and my area is 25 square roots of 3 units squared. Notice that my answer is in simplified radical form. The reason I can multiply is because I'm multiplying 5 times 5 and I'm not adding. If this was a plus sign here, I could not add 5 plus 5. Kind of like if I have x plus y, to simplify x plus y, I just get x plus y. I cannot add unlike terms. But if I have x times y, I can multiply x times y and just get xy. In my second example, my perimeter is going to be 16 plus this length plus this length. Well, in order to find those lengths, I need to do some problem solving. To figure out this length, if I look, it's the hypotenuse of this right triangle. I'm just going to call this side right here x. So to figure out x, I need to take 8 squared plus 6 squared and set it equal to x squared. So I have 64 plus 36 equals x squared. 64 and 36 gives me 100. Take the square root of both sides. So x equals 10. So this length is 10. Now I need to figure out this length. In order to figure out this length, I'm going to first figure out this entire length. I'm going to call that entire length y. So to figure out this entire length, I'm going to look at this big right triangle. And then this big right triangle, my hypotenuse is 16, my one leg is 8, and my other leg is y. So if I look at this, I have 8, y, and 16. So to figure out y, I'm going to take 8 squared plus y squared and set it equal to 16 squared. 8 squared is 64. 16 squared is 256. Subtract 64 from both sides. So y is going to equal the square root of 192. I need to simplify 192. So I'm going to find a perfect square that divides 192. So I'm going to start with a big perfect square, like 144. Nope. My next smallest perfect square is 121. followed by 100. I missed 64 along the way. There it is. 64 and 3. The square root of 64 is 8 square roots of 3. So y is going to equal 8 square roots of 3. So this entire length is 8 square roots of 3 long. So how far is it from here to here? If I want to find just this distance, I'm going to have to take this entire length, 8 square roots of 3, and subtract off this length. So from here to here is 8 square roots of 3 minus 6. Which makes sense. If this entire length was 20 and this length was 6, this length would have to be 14. To get that 14, I would take 20 minus 6. So if this entire length is 8 square roots of 3, to find just this piece, I'm going to subtract off 6. My perimeter is going to be 16 plus 10 plus 8 square roots of 3 minus 6. Now I need to combine my like terms. 16 plus 10 gives me 26. Minus 6 gives me 20 and 8 square roots of 3. Now this is an example where I cannot add 20 and 8. Here I could multiply because there is multiplication. Here I have addition. These are unlike terms. This is 20 integers and this is 8 square roots of 3. Integers and irrational numbers are not like terms. To find the area, I'm going to need to take 1/2 times the base times the height. So I'm going to have 1/2 times my base is this length, 8 square roots of 3 minus 6. But I need to take 1/2 times this entire thing. So even though there's no parentheses here, before I do any math, I'm going to add in parentheses. I'm going to group this length together because I want to take 1/2 of this and this times my height. And in this case, my height is this measurement, 8. So now I need to simplify. I'm going to distribute the 1/2. 4 square roots of 3 minus 3 times 8. But I still want to take 8 times this entire length. So I still need parentheses. And now I'm going to distribute 8 from the right side. So 8 times 4 square roots of 3 gives me 32 square roots of 3 minus 24 units squared. So even though there wasn't grouping symbols around this 8 square roots of 3, I needed to add them in before I multiplied. And the last problem. The perimeter is going to be made up of 4 plus 4 plus this length plus this length. So I first need to figure out this length. I'm going to call that length x. And x happens to be the hypotenuse of this right triangle. So I'm going to take 2 squared. I'm going to do this work way over here. 2 squared plus 4 squared equals x squared. 4 plus 16 equals x squared. 20 equals x squared. So x equals the square root of 20, which simplifies down to 2 square roots of 5. So this side is 2 square roots of 5 long, which means that this side is 2 square roots of 5 long. So my perimeter is going to be 4 plus 2 square roots of 5 plus 4 plus 2 square roots of 5. Combine my like terms. 4 and 4 gives me 8. 2 square roots of 5 plus 2 square roots of 5 gives me 10 square roots of 5. Excuse me, 4 square roots of 5. Because I have 2 square roots of 5 plus another 2 square roots of 5. So I'm going to add 2 and 2. I'm going to add just my coefficients. My area. I have a parallelogram, so my area is going to be base times height. Now there's a number of ways to get this answer, but the way that I'm going to look at this is I'm going to say this length is my base. If I rotated this parallelogram and I rewrote it like this, the base of the parallelogram would be 4, and the height would be this length right here, 4. So my area is going to be 4 times 4, which is 16 units squared. I could also find this area by finding the area of this entire rectangle and then subtracting off these two triangles. So the area of my entire rectangle is going to be 4 times 6, and then I would have to subtract off the area of this rectangle, which is going to be 1/2 times 2 times 4, minus the area of this rectangle, which would be 1/2 times 2 times 4. And if I simplified that, I would have 24 minus 4 minus 4, which is 16. Either way, I get the same answer.